What is up guys, Brandon here, and this is a very special video for me today because I'm going to be showing you guys the first look at my Raspberry Pi handheld retro gaming console that I've made over the summer. So here's your first look at it. There you go. So in this video I'm going to be showing you guys what went into it, the internals, how it works, operating system, different modifications I made, and just like a general overview. This isn't a tutorial, but it'll give a good idea of what components I have, what components work well, what didn't work, and things like that. So I think this will be a good starting point for anybody looking to make their own. So without further ado, let's get into it. So before I go into the internals, I'm going to talk about the case and the things on the outside of the case, and then I'll go on to the internals. Of course, I am running RetroPie. I'm just doing the regular 32-bit. Of course, you can get the unsupported 64-bit, which I did try, but a lot of things I was trying to do modifications-wise didn't work with that version, and even the benefits just didn't really outweigh the cost for that. You know, with the 64-bit, you can run Wii and GameCube, but I could only get a few games of those to actually run well, and I didn't really have the airflow that I needed in this case to be able to overclock. So it just wasn't really feasible. So that's why I just decided to go with the 32-bit version of RetroPie, but that's getting a little off track. Let's talk about the case. So the case, I actually did not design the case. I did 3D print it with my own 3D printer, but it was designed by a guy named Donald Simonet. I think that's how you say his name. I could be getting that wrong, but it's about a almost 4-year-old case, 3.5 years old, that he designed for a project very similar to mine, although it was different in a few different ways. But the thing about this case, although it did work, and that's all I really wanted, I just wanted a case that worked. It didn't work that well, and of course it is listed on Thingiverse as a work in progress. And also Donald, also from his blog, he was working on a version 4.0. This is the 3.0 case that I have. He was working on a 4.0 case, but I contacted him and he said he ran out of time and wasn't really working that well. So I had to stick with the 3.0, and I'll get into the downsides of it in a little bit. But overall, it did work. I did need to do a number of modifications to get the things that I wanted to put on it so that everything would work the way I wanted it to. And some of the things were missing from his files, so I had to add them in myself because he used different parts. I wanted to 3D print my own. Some of these things were the D-pad. I also added a speaker grills on this piece, and I'll have the link to my modified ones. That's not going to focus, is it? So I added these speaker grills to this piece right here, and those links will be in the description below to his build and also my modifications. I also 3D printed my own buttons for the display controls, because he used different buttons. I think his were like rubber buttons, but I needed to 3D print my own, so I did that. I also modified the buttons that he used. I put the A, B, X, Y, start and select like indentations on them, so that you can actually see which buttons you're pressing. There are a few air vents on the case, which is nice, and also on the bottom of the case there's a little air hole right here next to the Pi. But right here, I don't know what he used these ports for, but I used them for the power switch, a 3.5mm audio jack, and a extra button that switches to keyboard and mouse mode for my custom controller that I made, which I'll get into a whole lot of information on that in a little while. But yeah, that's pretty much the case. Also, it's on right now, and the fan inside it's really loud, and it vibrates really bad. I don't really know how to fix that, but it's not the greatest. I'm just kind of dealing with it for now, but that's something I definitely want to fix in the future. I don't really know why it's doing that. It's not, I don't think it's pressing against anything. And see, there it goes. It's not as loud. Sometimes it's louder, sometimes it's not, which is weird. Um, but yeah, so that's pretty much the case. It does get pretty warm on the bottom right underneath where the Raspberry Pi is. And also, you can see right here, there's some, the USB ports are accessible right here. Now, one of them, I believe it's this bottom one, is being used up by the controller inside. So only 3 of them are available. But it's also got an Ethernet port, and it's got obviously Wi-Fi and Bluetooth, which is super nice. But it works great, and it's got about a little over 2 hours, probably like 2 hours and 15-20 minutes of battery life, which isn't great. But realistically, I'm not really ever going to use it for that long. I haven't tested how long it takes to charge the battery yet, but probably takes like, I'd guess it takes a while, probably like a few hours, 2-3 hours probably. But yeah, so that's the case. So now I'm going to open it up and show you guys the internals. Alright guys, so to disassemble the case, you can just flip it around, and there's going to be 4 screws on the back. They do protrude out, which is kind of a bummer, but that's just the way it is. And this corner, and the screw that's supposed to be in this corner right here, the screw hole wasn't aligned, and so it just doesn't work. But 3 work pretty well. So we can just unscrew these. Alright, so once you finish taking those screws out, you can gently lift it up, and there are wires attached from one side to the other. Looks like there we go. Got a little attached to the hot glue there. So this is the case. As you can see, there is a lot of stuff going on, but I'm going to break it up by top half and bottom half. So let's talk about the bottom half first, because that's got a lot of the main components. So first off, we have the Raspberry Pi 4, obviously. This is the 8GB model, and I also have on top of this a little low profile heatsink / fan mount on it, and it's just screwed in, and those screws actually go through the heatsink, through the Raspberry Pi, and into the screw holes on the case, which is really nice. So I just need 2 screws to hold it together. Next to the Pi is the 3.7 volt 4500 milliamp hour battery. Not super ideal. It's kind of a small size battery, but it works. In the future, if I make another version of this, I'd want to use a larger battery. Also, a lot of builds use the 18650 cells because those have more capacity, and they also provide more volts if you use them in series, which is nice. This one is 3.7 volts, so I had to use a booster, which leads me to the next component. This right here, this black board right here, is the Retro PSU from Handheld. Obviously, everything's linked in the description below. But basically, this board will boost the 3.7 volts to 5.2 volts, which is what the Pi and the screen needs. And it also supplies up to 6 amps, which is really good, because I did try a few other, I did try a few other voltage booster boards, but those only supplied like 2 amps max, which is not near enough, because the Raspberry Pi needs, I think, like 3 amps, which is to be like pretty good. And the screen needs probably 1.5 volts or 1.5 amps. And then also the controller also needs a little bit of amps, and the fan. So you got a lot of amps going on. 6 amps is good. I actually did have to get a replacement from Helder. He was nice enough to send me a replacement because I fried my other one. But this one has worked great. And I will say, if you are going to build your own, to get the 6 amps, you do have to solder together the J1 pin right here. But I'm also using both the Raspberry Pi and the screen on one output because this board right here, this purple board, you might not be able to see it because the this wire might be in the way. But this purple board is the safe shutdown board, which was a huge lifesaver because, as far as I know, this is the only safe shutdown board that works with the retro PSU, because the other ones, there's a ton of videos on YouTube about a power off button for RetroPie, Raspberry Pi, which I tried, and it worked for the most part. But what it didn't do was it didn't completely shut off the power supply unit board, which means that the fan was still getting power, it was just draining battery, which was not good. I could not have that. So I decided to get this board. This is from, where's it from? I'll link it in the description below. I can't for the life of me remember where I got it from, but it'll be in the description below. But the guy who made this board actually had like a 25, sent 25 emails back and forth to the guy who made this, because for the longest time I could not get it to work for the life of me. But what I actually had to do was, originally I had both outputs enabled using the J2, the pin J2, and that's what was making this board not work. And it took us like forever, like multiple days, emailing back and forth to figure that out, because this was originally designed for the Retro PSU V1. I think I have the V3 board. So if you're using this safe shutdown board, you do have to use only one output. Now he might release a updated board, so if he does, then you should be able to use multiple, but for now just one output. So yeah, that's the safe shutdown board, and that was a lifesaver, like I was saying, because the safe shutdown board here actually cuts off all power from the PSU, just shuts it down, and it also implements the safe shutdown on the Raspberry Pi and the screen as well, because I have the screen wired up to it as well. And I'll do a more in-depth video with actual wiring and everything, hopefully soon. But if I don't get a video out, I might not be able to, because I'm getting ready to go out to college. If I don't get a video out, I should be able to at least get a written instruction tutorial out on my Hackaday page, which will also be in the description below. But anyways, that's the power down setup I have here. And what's nice about the V3 PSU is it has a USB-C jack, and also pin J3, you can close that to be able to get to allow 3 amp charging, which will make it charge a lot faster. I don't have a 3 amp charging brick right now, so I'm just using the regular 2.1 amps, which charges, it's decently fast, but that works great. I like the USB-C. It doesn't it's not flush with the case because it wasn't meant for this board, but that's alright. But anyways, that's the power supply setup. Next we have the HDMI cable, which, as you can see, it's this really thin cable. It's actually made for for FPV drones, and I bought them in three individual parts. I got I believe this is a 20 centimeter FPV cable. I also got the mini HDMI. I think it's mini, it might be micro. Pretty sure it's mini HDMI adapter, and then also just a regular HDMI adapter for the screen. So that's how that works, which is super clutch because it saves a ton of space and it works great. And then obviously the fan I have wired directly to the GPIO pins on the Raspberry Pi, and the safe shutdown board is wired to the Pi, as well as some other things. And then right here on the right side you see this. This is a absolutely massive glob of hot glue right here. As you can see, hot glue is the theme of this build. Tons of hot glue. But right here underneath the hot glue is the 3.5mm audio jack, which is wired directly. I actually just took it off of the actual screen. It was originally on the screen. I just desoldered it, wired up the wires on the screen, and just extended it over to this side, which was super clutch because now the screen also it has audio drivers. And so it actually drives the speakers and the 3.5mm audio jack, which is so clutch because it also seamlessly transitions when you plug in the headphones or something. Speakers automatically cut off. So I didn't have to do any weird stuff in like programming or whatever to get that to work. It just works great because it's all running off of the actual screen. So that was super nice. The speakers I have, I hot glued those in as well. Those are actually from an old Toshiba laptop. All the parts are going to be. I won't link the parts in the description. The parts are linked on my Hackaday page. So if you want to link to all the parts, go to my Hackaday page and check those out. So yeah, those are from the laptop. But these are really nice because since they're laptop speakers, they're pretty loud, like pretty like pretty loud, and they're good quality. So that's nice. Right here is the button to switch to the mouse mode, so you can use the joystick as a mouse. So anyways, that's the bottom half of the board. Now let's talk about the top half. So the top half also has a lot going on. Originally, I had to rewire the controller like two and a half times. I had to rewire it twice, the whole thing, and then the last time I had to rewire it again because the D-pad was messed up, wasn't working right. So I had to completely take that off. It was a total nightmare. I also had to move it. It was originally in the center, but then the fan got in the way. I had to move it. But finally, I got it to work, and it's all set up now. So, again, these speakers are right here, and the audio jack's there. The joysticks, this is clutch because a lot of joysticks, like if you get the Adafruit ones or just random like joystick breakout boards from like Amazon or something, those are usually not very good quality. But these actually had for some other project. I can't even remember why I bought this, but I had just a cheap like knockoff USB like Xbox style controller, and I just literally like cut off with scissors, just cut off the joysticks and just used those. Found some pinouts and they work great. Wired them up to my Teensy, which I should probably mention. This is the Teensy right here. It's the Teensy++ 2.0, which is a pretty old board. I don't know if I recommend this specific board. I didn't really have any reason for getting it, except for that I knew it had a ton of pins, and that's pretty much it. I just knew it had a lot of pins, and I was pretty sure it had enough that I needed. But I'd probably recommend, I'm not going to recommend a specific one because I don't know enough about it, but I'd recommend getting a newer one because this does use mini USB, which is really hard to get cables. Like, hardly anybody makes mini USB cables anymore. It does come with one, I'm pretty sure, when you buy it. But that was kind of like weird because I had to buy a mini USB cable to be able to wire it up to the Raspberry Pi, because the one that I had, it didn't work. I don't know why, but it didn't. But basically I just wired it up to the USB port on the Raspberry Pi, and if you want to look at the code that I used for this, it'll be on my Hackaday page, like everything else. But yeah, basically I just like picked a pin, I wrote it down, each pin, what pin I wanted for the different, for the different buttons. And I had to like wire it in a weird way because I had to wire it in a way that wouldn't interfere with the fan. So I had to like send everything down here and around to this side. But yeah, basically I did all the buttons on the right side of the pins, all the buttons on the left side, wired to the left side of the pins, and then of course the joysticks to the analog pins. So yeah, it really looks super complicated, but it's really not as complicated. It's really not as complicated as you might think. And of course, as you can see, the buttons I just used tactile buttons, like these kind of buttons, just tactile buttons for everything. You can use like those mesh button things, but I didn't really want to figure out how to get those to work. Push buttons, tactile buttons are just way simpler. It's just wire up 2 wires and it works. So I just used tactile buttons. And perf board, I just attached them to perf board, soldered them together, and soldered all the ground wires together, and then just wired it up to the TC. Got my code working, and yeah, it pretty much just works. The code that I'm using right now, it's not the best. Um, it could use some tweaking. I'd like for it when it's in keyboard mode. The main thing is when it's in keyboard mode right now, the only controls I have is mouse with the joystick and then left and right click with A and B. Um, I would like it so the other buttons could be like mapped to keyboard buttons so that I could like use it for like PC games that usually use a keyboard, something like that. But I don't know, maybe. I mean, left and right click and mouse, most of the things that you would need. But yeah, so it works fine. Um, but it could use some improvements. And then also the last thing is obviously the screen is right here, and then connected to I wired up some wires to the screen control buttons right here, and put some tactile buttons on some perf board, hot glued it, and wired those up so that I have access to those on the outside of the case, which was super clutch, because that's super nice to have because I can adjust volume that way as well as like brightness and things like that. But yeah, anyways, I think that's pretty much it. Like, it seems super complicated, but like this is probably the simplest way you can make a handheld. There's a ton of handhelds out there that are like insanely over-engineered. Well, maybe not over-engineered, but like tons of engineering stuff. Like really, it's not that hard. A lot of people, especially me included, when I first got into this and was researching, it just seemed really daunting, and I didn't know like really what I was getting myself into. Um, but really, like, you really just you gotta get a controller. You gotta figure out what controller board you want to use for the controller. You gotta get your Raspberry Pi. You gotta pick out a battery, power supply, and once that all works, make sure it fits in your case, and then you're pretty much done. So, of course, you can tweak up the operating system, things like that. But yeah, there's really not a whole lot to it. But the reason I say that there's not really a whole lot to it is because I want people that are like, if you're thinking about getting into this space, I don't want you to be like, I don't know what to do, I don't know what I'm doing. Because a huge thing for me when I was building this was the community support. Like with my PSU and the Shutdown board, I emailed Helder and the guy who made the Shutdown board, and they were super nice, super helpful. Um, and I put a ton of like forum questions on different forums, and everybody was nice and helpful. Got everything figured out for me. So especially if you're like thinking about I might want to do this, but I don't know like what to do. Just get into some of these forums. RetroPie forum, Sudomod, BitBuilt, things like that, and ask some questions. Look up other builds that people have done. Get inspiration from those. And then once you feel confident about how you want to do yours, which case you're going to use, figure everything out first, and then get it together and build it. And I think you'll find out that it's a lot simpler than you might originally think. But anyways, I think that's all I'm going to go into this video. I realized I didn't really go into any software stuff. I did kind of talk about it a little bit, but maybe I'll do that in another video, something like that. But I'll definitely try to get out some more tutorial videos that go more in depth on all this. But anyways, I think that's a pretty good representation of what I did, how I did it, and things that went into it. So I hope you guys did enjoy this video. I hope it helped you out a lot and helped you learn something about what goes into this stuff. Thanks for watching. If you did like the video, make sure to hit that like button, comment what other videos on this topic you'd like to see, and make sure you subscribe if you're not already. So anyways, thanks for watching. I think I've said that like 3 times now, but have a great day, guys. Peace.